Okay, so here's your very first audio experience on the physics blog, and I'm going to do a rocket problem for you. And this is question number 4. It's the front of the 3rd page, and there are several things that we want to know with this rocket problem, or we need to make assumptions. And the first thing of which is we got to break it into 2 parts. The first part is while we have an acceleration, and the acceleration at the first part happens to be 7.88 meters per second squared. And in the first part, we also have a change in time. And that change in time for this acceleration equals 1.98 seconds. Now, after this initial acceleration during 1.8 seconds, it then has a second part here, and that second part is where it slows down. And during that second part, acceleration equals that of gravity, which happens to be negative 9.8 meters per second squared. And at the pinnacle of its motion, the final velocity is 0 because it stops. Now, there's several different things we need to be able to find. First of which is the final velocity of the first part of the trip and the change in distance for the first part of the trip. Now I'm going to call that change in distance 1 because there's going to be 2 change in distances that we're going to add together. Change in distance 1 and change in distance 2. And that'll find us delta D total, which will be the sum of D1 and D2. Now, we need to find a final velocity for the first part of the trip because that in turn will end up being the initial velocity for the second part where it starts to decelerate. And to find the final velocity, we can say VF equals A delta T. And we can then find change in distance for the first part by saying 1/2 A change in time squared. Now when we solve these 2 things, for the first of which I take my acceleration, which happens to be 7.88 meters per second squared, and I multiply that times my time of 1.98 seconds, and I end up with something which is 15.6 meters per second. And then my change in distance, I would say 1/2. I would use, again, 7.88 meters per second squared. I multiply that times the 1.98 seconds, and I square that value. And that's going to end up getting me 15.4 meters. Now that 15.4 is my first distance that I'm going to add to the second distance I'm going to come up with in a moment. Now that VF, with which I said was 15.6 meters, applies to the second part of the journey, which is going to be 15.6 meters. And knowing this initial velocity and the acceleration and the final velocity, that allows us to solve for delta D2. Because we have an equation on your equation page, which is going to say VF equals the square root of VI squared plus 2A delta D. We're going to solve this for, well, delta D, because here's our unknown. And that unknown needs to be solved for rearranging this. And this will rearrange to VF squared minus VI squared all over 2A. And that'll equal your change in distance. And so let's put some numbers in here. 0 minus the initial velocity that came from the final velocity of the first part of the trip. And so that happens to be 15.6 meters per second. We square that value and we divide that by 2 times a negative 9.8 meters per second. And meters per second squared, and that should get us a value of 12.4 meters. And that's our second distance, 12.4 meters. Add those 2 things together and you found the ultimate height that rocket reaches. Thanks for playing.